video, we will be talking about linear relations. Then we'll be talking about standard form, slope-intercept form, slope, and then parallel and perpendicular lines. And so doing that will then lead us into doing some x and y intercept stuff. So I'm going to break this into two separate videos. So let's go ahead and get started on this one. So when points on a line or points on a graph lie on a straight line, they have a linear relation. So then we can see that this equation would be that graph. Nothing major there, just some pretty basic stuff. Now, the standard form for writing an equation of a line is going to be ax plus by equal c. Now, make a note to yourself that a has to be greater than or equal to 1, meaning that in this form, the number that is in front of our x has to be either greater than 1 or equal to 1. So we can't have negative numbers and we can't have fractions in front of that x. So let's go ahead and do an example. And basically the way that you approach these is you manipulate them like you would do equations. This is why we did some of that stuff. So if we look at number 1, we have negative 5x plus 6y equal to negative 12. The big thing here is we need to take this negative 5x and we need to make it, we can keep it just 5x. So the way we get rid of it is we divide by negative 1, and that will give us a positive number. But since we did it to this, we also have to do it to each term here. If this 6y were not here or we're on the other side, we would have to do it by both sides as well. So since there's those multiple terms, we have to do it by each term. So this will give me 5x minus 6y equal to 12. And that is in standard form. I'll do one more. I'll do number 2. So on number 2, we've got y equals 2x minus 9. We need this 2x to be on this side. So we're going to subtract by 2x, which will give me negative 2x plus y equal to negative 9. Then we're going to have to come back and divide by that negative 1 by each of these to make sure that this number that goes with a is greater than or equal to 2 or to 1. So then that gives us 2x plus, well, actually that'll be negative. So it'll be negative y equal to 9. So that's just putting stuff in standard form, not super complicated. Next, we've got slope-intercept form. So you've probably seen this one. This is y equals mx plus b, or f of x equals mx plus b. So you could see it either way, or g of x, h of x, blah, 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 blah. Where m is the slope, so m is always going to be our slope, and b is our y-intercept. So we use that for graphing purposes. Now, slope is the same thing as rate of change, and you can think of that as rise over run. I'm sure you probably heard that. So rise over run, that means that's how we interpret how to slope or how to graph slope. So there are 4 types of slope. There is a positive slope. That's not how you spell positive. There's a negative slope. There is a zero slope. And then there is a undefined slope. So this is what each of those would look like. So if you had a line here, anytime a slope is increasing from left to right. So you read this like you'd read a sentence. So moving from left to right, if this goes up, that means it's positive. And the opposite is true for a negative. So a negative slope, looking at it from left to right, will be going downwards. So So one's going almost up a hill, one's going down a hill. A zero slope is horizontal. So the slope for a horizontal line is always 0, and then the opposite is true for undefined. So undefined means our slope is vertical, or our line is vertical. The slope of a vertical line is undefined. Okay, so then we'll write the equation in slope-intercept form and graph it. So I'm hoping we all know how to graph these. This first number in front of our x is our m, so that's our slope, which is rise over run. That second number is our y-intercept. So that's our starting point when we go to graph this. So we're going to go 1, 2, 3, 4, 5, 6, 7. So we're going to start out right there. Actually, let me get rid of that. So we're going to start out right there. Then we go 2 over 5. So our rise means that's how much we go up or down. The top number is. The bottom number is our run. So that means we can go left and right. Now, typically you would, if you had enough room, you could go up 2 over 5. But if you don't have enough room, so instead of going up 2 and over to the right 5, we can go down 2 and to the left 5, and it'll give us the same thing. So go down 1, 2, over 1, 2, 3, 4, 5. And that will be our graph. I can't draw completely through it, but that's what it would look like. And I'll do number 8 as well. So number 8, our slope is going to be -1. So m is -1, and our y-intercept is going to be 2. So that means we're going to start at 2, and then we're going to go down 1 and over to the right 1. So that would leave me there. So rise over run just means rise is the up or down, and run is the left or right. And then we just draw a line through those points. All right. Now, horizontal lines, like we talked about, and vertical lines. So if you want to write the equations for these, the easiest way I know to remember it is whatever axis this line goes through, so intersects with, you notice that this intersects at this point here on the x-axis, which would be -3. So you would say x equals -3. That's how you would write a horizontal or a vertical line. Now the opposite, or you can use the same type of logic for doing horizontal lines. So this line crosses the y-axis there, so that would be 1 on the y-axis, so y equals 1. All right, and then parallel versus vertical, or parallel versus perpendicular. So the slopes of parallel lines are the same or equal. So if you have parallel lines, their slopes are going to be identical. And if you have perpendicular lines, their lines are negative reciprocals. Meaning that say your m for one line is 1. A line perpendicular to that, its slope would be -1 over 2. Or actually, it would just be -1 because that would be the reciprocal. All right, so I'm just going to do one of these to show you. Okay, so let's look at 13. The best way to find slope is to put these in slope-intercept form. So I'm going to take my first equation and put it in slope-intercept form. So I've got 10x plus 5y equal to 5. So I'm going to put this in slope-intercept form. So I want it to be y equals mx plus b. So the first thing I need to do is move this -10 to the right. So that's going to give me 5y equals -10x plus 5. Then I need to get this y by itself. So I'm going to divide each side by 5. And each term by 5. So that'll give me y equals -2x plus 1. And then I need to do the same thing for this other equation so that I can look at my m and see, compare those two. So we've got negative x equal to 2y plus 16. So I'm going to move this 16 to the other side. So that'll be negative x minus 16 equals 2y. Then you need to come and divide each of these terms by 2. And I'm going to flip this around because you can just flip this around. So y equals negative 1/2 x minus 8. So these are our two equations that we're comparing. And we want to compare the slopes. So the slope for this one is negative 2. The slope for this equation is negative 1/2. Now, these have to be negative reciprocals, which means if one of my slopes was negative 2, the other slope would have to be positive 1/2 because that would be the negative reciprocal, meaning I would flip that sign. So you flip it and change the sign. That's what a negative reciprocal is. So in this case, your answer would be neither, because it's not the same and it's not perpendicular, so it's neither. I'll let you guys do 14, 15, 16. We'll work through examples in class, and we'll also, there will be a part 2 to this video. So we'll bang out two videos again.